About transformers for several weeks now, and this will be the conclusion of it for the basics. So when we talk about this, we talk about the individual, how they're isolated. So with this, you've got, if you look at this, you actually will see you've got three separate transformers. For a three-phase transformer, you've got three separate transformers. Now, on three-phase transformer, what is your expectation if I put my continuity test between H1 and X1, is it going to ring?
No.
Doesn't it connect through the windings?
No.
No connection.
No. Only one
Now,
connecting is the auto
H1,
transformer.
H1 to H2,
Yeah.
yes or no? Come on, give me, be bold here.
I say yeah.
No.
It's gonna be connection.
Should that be bumping phases?
It's
Wouldn't
on
it?
the same side.
What?
It should be continuous. It's on the same side.
Zero.
Oh,
H1 and H3, and I'll get into why here in just a second. But H1 and H3, y'all expecting continuity?
I guess, yeah.
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 How about now H1 to HO?
No,
I
it'd
don't
be
know about
going
the I don't know about the
It'd be
other.
grinding it out.
I didn't say about the other.
Anybody else want to be bold and proclaim an answer? H1 to HO.
Yep. That's confident.
Yeah.
All right. Does anybody want to explain any part of this about why? No? Okay. So we talked about this. So all this is a winding. It's a piece of wire. It comes from this terminal right here, wraps around the magnet, and comes over to this terminal right here. And and if you look, you guys aren't going to be able to see it, but there's a diagram right here that actually tells you that's exactly what's happening. On this particular one, there's a diagram that shows H1 connected through the coil to the center tap, which is HO. And then from the H1 to H3, it's also connected through that center tap. So that's why you have continuity between all of those. Now, why doesn't it trip? Jonathan mentioned, he says, well, it'll buck phases. It'll be a zero continuity. Why doesn't it trip then? If I've got zero, if I put 480 volts H1 and H2, why doesn't it trip if I've got continuity? Magnetic field, he got it. So it creates a magnetic field that actually reduces that actually increases the resistance that the power is going through there. That's why you turn it on, you'll hear the hum. The hum is just it converting from, in this case, 240 to 480. But that magnetic field actually creates the resistance. So it keeps current from being able to flow. All right? And then when we put load on the other side, then it allows current to flow. So long as we've got these in place, we've got that magnet in place, we have the resistance to keep this from tripping. There is no physical connection in this kind of transformer. This is a dry type standard transformer. There is no physical connection between the primary side and the secondary side. Zero. No physical connection. Just real quick side note, sometimes they'll use a transformer that goes from 240 to 240 or 480 to 480 or something like that as a surge suppressor, because the voltage spikes that will come on this side will have no physical connection to the other side. And it will actually absorb that spike. So sometimes an isolation transformer can be used as a transient voltage surge suppressor. So you've got, on this particular one, you've got 240 volts on the primary and 480 volts on the secondary. Most of the ones we deal with are just the opposite. We come in with 480, usually we come out with 208. And this one, we've got Jonathan actually going to install this bad boy, and he's going to be coming in with 240, and it's going to have 480 coming out. Now, we talked about windings ratios. What's our windings ratio here?
2 to 1.
2 to 1. Because it's 480 and 240. It is that simple. Now, so we're going to have, let's say we've got 240 volts coming in there, and we want 480 out. We want 480 coming out. Do we have an option here that you guys know of if you've only got 230 volts coming in to address still trying to get 480 coming out? Transformer taps. The transformer taps are listed on here as well. Now these are very important for us because if we need to account for a voltage drop coming in, like we just said, if we have 240 coming in nominal, but we only actually have 230 or 228 or anything like that coming in, you can use the transformer tabs and it lists what the voltages that you can have coming out here are. And all you have to do is instead of looking at the way that they've got it already hooked up, you can use the numbers that they've got based here, and you can see they're written on that sheet, and you can change the tap on this transformer on the front of this coil. And all it takes is taking this wire and move it to a different place, and it changes that ratio. And it changes it just a little bit to where you can come in with a 1 voltage and come out with just a slightly different voltage because the ratio changes. Go ahead.
So how do we coming in with 480, but we want to get 240 three-phase coming out? Like what we got up at.
So all you have to do is reverse it. The ratio, you're going to use the ratio the exact same way. You're not going to know it based on these numbers, but you're going to know what the ratio is. And that's why it's important to know what the ratio is so that you can do the math going backwards instead of forwards. But you can do it the exact same way, which is exactly what we did, by the way. They wanted 230 volts coming out, not 240 volts coming out of that transformer, if I remember right. I'm pretty sure that's the way it worked.
Wow.
So we ended up with 230. Why'd they want 230?
I think they want 240 because
It could be.
that's what they got coming out.
That could be. I know. I remember we changed it instead of because they needed a different voltage coming out of their equipment.
So does it have to be a Y or delta like a?
Yeah, it won't make a bit of difference. The ratios are still the same. It's just a matter of where the connections are. Now, you bring up another good point. On this HO, now let's get into the fundamentals real quick of this, because I know we went into a lot of the theory and the connections, the ratios and all that. Let's just talk about the field and what we would do in the field. In this particular instance, our primary is 240. So where are we hooking up 240 here?
Top.
How do you know?
Because the bottom side has XO for neutral, so you get 277 480 on the bottom side.
Where you going?
No.
You're going to 480?
Yeah.
What's that?
Side checking. You're looking at the bottom.
Look at the plate.
Oh,
You're looking at the bottom.
Yeah, we're gonna look at the plate. You're gonna look at the plate. If you're coming in at 240, all you're doing is checking the plate and making sure it's saying what you need it to say. Now you can still check this and do resistance tests to see what the ratios are, see how long the windings are. But we don't have to do that here. We've got the plate. So we're gonna come in with 240 on this top side. And then on this bottom side, we have the H1, H2, H3. We're gonna have 480 coming out of that. That's pretty clear. That's pretty intuitive, right? H1, H2, H3. We got 240 coming in, 480 coming out. In this case, what do we do with that HO?
We're using it for tomorrow, or
In any case, well, you know,
you gonna bond it? Oh, good.
what?
Bond it?
Yeah, you're still gonna bond it, and that's gonna just stabilize your voltages.
Can you touch on one thing too? So
Sure.
you just mentioned H. What identifies the primary and the secondary side? What letter?
So, in general, the H will actually determine what the higher voltage is. X is the lower voltage. Primary and secondary is, because it works off of ratios, they can be reversed, but they are usually designed to work in one direction or the other. And the only reason they do that is because there is a voltage drop that comes from the transformer, so you'll actually have a little bit of a bump going one direction or the other. But at my house, I did exactly that. I reversed the transformer. I have such a long distance going from where the pole comes in. I installed 2 transformers, one of them with a 240, 480, so I reversed it and then brought it to the transformer at my house and brought it from 480 back down to 240, single phase. So in this case, we're going to bond the HO. We don't need the HO for anything. We're not running a neutral in this particular instance. But we're going to go ahead and bond the HO to stabilize the voltage. With this 240 coming in, if we were to run this backwards, and we came in with 480, and we had this 240 coming out, what would we bond at that point to stabilize the voltage?
The same.
Oh,
You got
you was talking about
this side right here, we've got it. You can bond it, you're at the neutral there. You know, if you were coming in as a primary on the H, it's already gonna be bonded at HO.
Would you do like you said last time in ground and phase? One of the shit, I forget what
You can bond one of the phases.
That's good.
You can bond any one of these 3 phases. Now that's a weird thing, isn't it? You can take that X1 right there, and you can do this in a 480 panel too, or a 480 transformer. And you can take H1 and run it straight to ground, and it won't trip.
Ooh-wee.
But yeah, it's a scary thing when
You
you
come
don't.
up there with me.
I've actually had that before. So it's a scary thought, but if you're on the back side of the transformer, just remember you're on the back side of the transformer, then you're okay. But if we were on this side, where we come in on the primary, and we ran it to ground, then it blows up because it's bonded at an HO somewhere else. Well, on this side, it wouldn't be bonded. Now, what Jonathan's going to be installing here, it's going to be 240 coming in, and that's already going to have a bond. You're not going to be able to bond any one of these 3 because it would blow up. But on this side, you will be able to bond it. All right. So this transformer looks a lot like most of the transformers you guys are going to be dealing with in the field, but it's just a little bit different because it's instead of on the high voltage is on the secondary, is on the Y side. Usually the secondary is going to be on the low voltage side. On the bonded neutral is going to be on the low voltage side. So it's the only difference. You guys just make sure you understand this part of it. The hooking up is the easy part. Understanding where you got to make those differences, where you got to use transformer taps, where you got to address the voltage differences, and where you got to specifically where you got to bond the neutral. That's a really, really big important step, is where you got to bond the neutral or corner ground the high voltage side.